Today we are on the last lesson of this unit. We're just going to break it up into 2 days. So today is over complex, polar, and the complex plane. So we are going back to imaginary numbers, and really we're going to be making connection between imaginary numbers and polar numbers are what we worked on in the last lesson in 6.4. So the first thing, when we did imaginary numbers back in Algebra 2, you did all of the operations. You added, subtracted, multiplied, and divided. The one thing you may or may not have done was graph them. So we're going to look at how do we graph them. So if you've got 1 plus 2i, we call the 1 is the real part, and the 2i is the imaginary. And we're not going to graph this on a rectangular coordinate plane, but if you notice, it's called a complex plane. And I know it's kind of difficult to see, but if you see the numbers along here, they're like they normally are, 1, 2, 3, 4. But if you notice the up and down, this is called the imaginary axis. And they are labeled I, 2i, 3i, and then going down negative on the bottom part as well. So if we want to go plot the point 1 plus 2i, we would go to the real part is 1, the imaginary part is 2i. We place that point there, and I'm just going to label that to be point A. Let's look at the next one, 3 minus 2i, or 3 minus I, so I would go to positive 3, go down to negative I, and let's label that to be point B. The next one, negative 2, positive 2i, and then finally if you look at the last one, it's I. If I wanted to write it in this format, in other words, if I wanted to write it an imaginary number, I would write this as 0 plus 1i. That means I'm not going any left or right on the real part, I'm just going up to positive I on the imaginary, and let's label that to be point D. We've got a few more over here. We've got 2 comma negative 3i. Again, let's label that A, 1 comma I. Okay, let's take a look at this one. We could rewrite this as 3 plus 0i. So I'm going 3 on the real, and I don't have an imaginary piece, so that would be C. And finally, negative 2, negative I. All right, so now what we're going to do is we're going to take these points and we can go ahead and plot them on the coordinate plane just like we did up here, but we also are going to change them to polar form as well. And I just want to point out the polar form of an equation. So if we go up here and take a look, if we're looking for the polar, notice we're looking for r, which is the square root of a squared plus b squared. Take a look. A is r cosine theta, so it's kind of like you're distributing, and B is your imaginary part. Again, you would be distributing r times the sine of theta. So again, r is your magnitude, just like it was when we did vectors, and it's also equal to the absolute value of a complex number. They also call it the modulus. And then theta, which is that angle, they call the argument. Okay, so let's take a look at the first one. If I want to graph it just like we did up here, this becomes 0, 3i. So we're starting at the origin, I'm not moving any left or right, and I'm going up 1, 2, and 3i. And what I'm trying to point out to you when we go and graph this, it doesn't matter whether it's in polar form or imaginary form, I should still end up at the same location. So we're going to take this complex number and we're going to change it to polar form. So if you take a look up there, let me write this out here. First of all, we want to find the magnitude, so that's your r, so we've got the square root of each one of these, so 0 squared plus 3 squared ends up being the square root of 9, which is 3. And some of you might have said, I don't really need that formula. I can just count it out. And you're right, if I'm drawing from here to here and I drew a vector, that would be 3 units. But just trying to show you again how the formula works. The second thing we need is that angle. And again, you might be able to think about that. Remember, on the unit circle in polar form, we start here, going to here, it would be 90 degrees, and you are correct. But again, let's use that formula. If you take a look at the formula, it says tangent of theta is b divided by a. So we've got tangent of theta is equal to 3 divided by 0, which means that inverse tan, and 3 divided by 0 is undefined. So we're going back to the unit circle, so you might have that handy. When is the tangent undefined? It's undefined at 0 degrees, or if you notice it's in radians, which would be at pi over 2. So this number in polar form would be 3 comma pi over 2. Now think about, how did we graph polar points in that last unit? Well, I would have a rotation of pi over 2 with a magnitude of 3. So I would rotate to here and I would count up 1, 2, and 3, and notice you end up at the exact same location. And the nice part about this graph right here, I cut and pasted. It's got your polar form, which are those circles in there, with the rectangular or the complex plane over the top of it. Okay, let's go again and plot this one. I'm looking at 2 comma 2i, so I go 2 and then I would go up 2i. Now again, just like we did, we're going to go change it to polar form. First thing I need is that magnitude. So again, I've got 2 squared plus 2 squared, which is 4 plus 4, which is radical 8, which is 2 radical 2. Next, I need to go and find that rotation. And again, if you think about it, that point is smack in the middle of 90 degrees and 0 degrees. So we should be expecting 45 degrees. Let's confirm it algebraically though. So the tangent of theta is equal to 2 over 2. That means I am looking for, when is the tangent equal to 1? So inverse tan equals 1. That is smack in the middle at 45 degrees, but again, in radian form, that would be pi over 4. So we've got 2 radical 2, comma, pi over 4. So let's think about if I had to graph this as a polar. You should end up approximately at the same location. So again, a rotation of pi over 4 would be smack in the middle. Typing in 2 radical 2 on my calculator. Go ahead and do that. 2 radical gives me a magnitude of about 2.83, which is almost 3. And take a look, there's a magnitude of 1, 2, and just shy of 3. So again, trying to make some connections, doesn't matter whether I plot it this way or I plot as a polar point, I'm still ending up at the same location. Okay, now we're going to be going backwards. It says write the complex number in standard A plus BI. Start by making a rough sketch of where I think that location would be. So first thing we're going to do is go ahead and distribute. We've got 3 cosine of 30 degrees minus I3 sine of 30 degrees. So let's go ahead and think about the sine of 30 degrees. And again, if you need your unit circle, grab that. 30 degrees would be here. That means my x is longer and my y is shorter. A longer x is equivalent to radical 3 over 2. And a shorter y is equivalent to 1/2. So we get 3 radical 3 over 2 minus 3i over 2. So I went ahead and converted these each to decimals. Again, we're going to approximate where we think this point is, and then we'll go ahead and change it to polar form. So I've got an x of about 2.5 and a y that would be actually negative 1.5. So 2.5 and negative 1.5 should put me roughly in there. And hopefully I'm going to confirm that when I go and flip it to polar form. So first thing I need to do is go and find that magnitude. So remember, I'm taking each one of these components and I'm squaring it. So I've got to square both of those. That would give me 9 times 3 over 4 plus 9/4. That gives me 27 over 4 plus 9 over 4. Eventually we get 36 over 4, which is the square root of 9, which is a magnitude of 3. Now we need to go find that angle. So again, we've got inverse tan of 3/2, and that's a negative 3/2 divided by 3 radical 3 over 2. Couple things I can do. These 2's cancel, actually those 3's cancel, so I'm left with negative 1 over radical 3, which simplifies to negative radical 3 over 3, and I'm looking for when is the tangent equal to that. So I know it's down here, and it's the less steep, which would be that first increment, which ends up being approximately negative 30 degrees, or negative pi over 6. So that complex number in polar form has a magnitude of 3 and a rotation of negative pi over 6. So let's go take a look. Each one of these, it looks like it's 15 degrees. So this would be 15 degrees, this is 30 degrees, and I have a magnitude of 3. So that means, again, out 1, 2, and 3, and we're pretty close to what we got when we estimated it all the way back up here. Okay, we've got one more to go ahead and take a look at. So again, we're going to go ahead and distribute. We've got 5 cosine pi over 4 plus 5I sine of pi over 4. So pi over 4 is smack in the middle. The nice part about that, both of the coordinates are the same. So we've got 5 radical 2 over 2 plus a 5I radical 2 over 2. So let's go figure out what 5 radical 2 over 2 is equal to. So that way, again, we can roughly estimate where it would be on that graph. Looks like I'm getting 3.5, and both of these would be 3.5. So let's go out 1, 2, and 3.5, and up 1, 2, 3.5. Looks roughly like we're right there. Again, we're going to go change it to that polar form. So the first thing I need to do is go and find the magnitude. Again, I'm taking each one of those coordinates and I'm squaring it. All right, so I've got 5 squared and radical 2 squared, so that would be 25 times 2 over 4, plus another 25 times 2 over 4. So take a look at what you have. 50/4 plus 50/4 is equal to 100 over 4, which is equal to radical 25, which means I have a magnitude of 5. And if you go and look at that graph, that's exactly what we're at. 1, 2, 3, 4, and 5. The second thing we need is the angle. So again, let's squeeze it in here. Theta is equal to inverse tan. And we've got both of these are the same. 5 radical 2 over 2 divided by 5 radical 2 over 2. That eventually gives us inverse tan of 1. So we're looking for when is the tangent equal to 1. That is 45 degrees or pi over 4. So again, this number in polar form would be 5, pi over 4. And again, if you take a look at where that point is, a rotation of pi over 4 is exactly on this line, and we already confirmed 1, 2, 3, 4. 5 is our magnitude, so again, whether we plot it in polar form or whether we plot it in that complex form, or ending up at the same location. So today really all we're doing is graphing both polar and complex and just converting back and forth between the two. If you have any questions, make sure you get on one of those Zoom sessions. I can answer those or help you with your homework.